So we are here at ETH Zurich, and we're basically here to celebrate and attend the webcast from the CERN, so the European Research Center of Particle Physics. And we have just heard the webcast where the presentations of the two big experiments were given. That was first the experiment CMS, the compact muon solenoid, where the spokesperson Joan Candela has shown the results of the measurements from last year and this year in basically with respect to search for the standard model Higgs boson. And then there was a second presentation by Viola Gianotti, the spokesperson of the ATLAS experiment, the other big experiment at CERN, who also covered their experimental results. So the present people are moving into the council chamber. There will be a press release and an answer and question session at CERN. And we are just having a break here at the moment, and then we'll have our own question and answer session.
What is the most important result that has been presented today?
Well, both experiments have independently analyzed the data and have found a new particle. They have made an observation which was not known before of a state which was shown to be at the mass around 125 GeV, a new thing. Now, what exactly this is of course the big question. People hope that this is the long thought for Higgs boson, but this is something we just don't know yet. Right? We need more information about the topology of this particle, how it decays, how it behaves, its own properties, and only then will we be able to really tell if this is really the standard model Higgs boson or not. What we see now is consistent with the standard model Higgs boson, but we just don't know yet. So of course we all look forward to take more data this year in the hope that by the end of the year we will have enough knowledge to be able to tell that.
This is a big effort done by a large community, which are people from physics, which are also technicians, and also using a lot of computing resources to analyze this data. Can you tell me what the contribution of supercomputing and computers is to the result presented today?
I think one of the real important points that have been achieved here is that the global community has joined their efforts. They have joined their forces in terms of resources, CPU, storage, and also organization of data storage, such that they can do a global analysis altogether. This is something which is new, right, which other communities have not done. And I think only by using the global resources of computing powers worldwide, we have been able to do the analysis so fast. You have to just keep in mind that the 25th of June, that's basically 2 weeks ago, the data taking stopped. And since then, all the data have been reanalyzed, and looked for this new particle. So this is a tremendous speed at which the analysis has been taking place, and this has would not have been possible without this huge amount of efforts going into the computing and the resources that we have at hand. In a virtual sense, of course, the experiment spans the whole world, right? We have collaborators from all over the world. It's really a truly international collaboration, both in the experiment, in CMS and ATLAS, right? There are more than 3,000 people altogether working in that experiment, working together. All nations are involved, and that works really well. And I think this is an achievement by itself. It's a social achievement as well.
You are a physicist. How important is this moment for you?
Well, this is probably one of the moments that all the physicists have ever dreamt of, right? You dream as an experimental physicist to discover something in the course of your lifetime. And this is one of these very, very rare moments. So we really enjoy it, but I think it will take a few days until we realize what it really means.
Okay, congratulations, Christoph Grab, for
Thank
what
you
reached and for all the community.
Thank you very much.
And we wait to see the rest of the results by the end of this year, early next year, maybe?
Yes, we hope so. And of course, we all hope that the data is good enough so we'll be able to answer that question. Is it really the standard model Higgs boson? Yes or no?
Okay. Thank you very much.
You're welcome.